Hi, I'm Monique.
And I'm Rachel, and we're going to talk about constructive interference between waves and destructive interference between waves. Constructive interference occurs when two waves come together and interfere. In constructive interference, the waves have a displacement in the same direction, so either two crests of a wave interfere or two troughs of a wave interfere. If two crests or troughs interfere, their amplitude is increased. We can see an example of constructive interference here. If I play the same song at the same time on both Monique and my phone, and I put the speakers next to each other, the noise is amplified. It's much louder here than it is here. Since we are on a desk, which is both rigid and smooth, the sound is amplified and sounds like an echo, which is a reflection of sound. Since we are dealing with sound waves, the sound is amplified by two compressions interfering or two troughs interfering at the same time.
Destructive interference occurs when there are two waves that interfere, but they cancel each other out. The cancellation happens because when the waves meet at a given point, they are at different displacements. This means that one wave is displaced upward, while the other is displaced downward. The two waves that are interfering, however, do not need to have the same amplitude. A big wave can interfere with a small wave, and if they have opposite displacements at a given point, then they will cancel each other out through destructive interference. An example of destructive interference is noise-canceling headphones. They work by creating waves with opposite displacements to the noise waves, which they are trying to cancel out. Workers who use jackhammers have noise-canceling headphones that produce waves that go against those that are created by the jackhammer. If a wave from a jackhammer at a given point is a rarefaction, then the wave from the headphones will have a compression at the same point. Therefore, the sounds will cancel each other out for the worker who is wearing the headphones.
Here we'll demonstrate what a destructive interference wave looks like.
With a slinky. Again.
As you can see, the two waves meet at the middle, but because they're at different points in the wave, one is displaced upward and one is displaced downward, the waves cancel each other out and die down.
In this image, you can compare the different types of interfering waves. First, you see waves with constructive interference. The crests and the troughs of the two waves that interfere match up, so the crest and trough heights are amplified. The next diagram shows waves with destructive interference, so their crests and troughs do not match up when interfering. But these waves do not have the same amplitude, so they do not entirely destroy each other. Instead, you are left with a slight wave. In the final diagram, you can see the effects of destructive interference with waves of the same amplitude. The crests and the troughs of these waves do not match up, so when the waves interfere, because they are exactly equal but opposite, they completely destroy one another, so you are left without a wave.